Okay, so hi everyone, it's good to see you again. Today we're going to work on minnow time, it's called minnow time because it's time sensitive, but I think it's useful to think of it as a lot wider than that. We'll get to that in a second. My talk today will be built of two parts. The first will be an introduction to minnow time, where I explain what minnow time does and how it does it, and explain the different specific parts. And then the second part, we will read through a script for a more complex task, so you can see how things come together and how some more involved tasks can look and work. And I already said this yesterday, but I really think that one of the best ways that you can learn how to use Minno.js is by reading code and understanding it. And I want you to start doing that and understanding how things work as soon as possible, as early as possible. And again, if at any point you want to ask anything, feel absolutely free to do so. And I I have a hard time following the chat when I speak. So just break in and say, hey, can I ask something? And I'll stop as soon as I can. Okay? So let me get this working. Okay. Do you see the good. So minnow time. What we did so far was work with a very, very close format for tasks. We used questions. We can have useful types of questions, and that pretty much covers everything that you do with questionnaires. The problem when you move to cognitive tasks or time-sensitive tasks is that they become a lot more complex and a lot more specific, where you need a lot of control over the stimuli you display and their timings and all the interactions with the user. And when we started working on minnow time, we started with a sort of with an idea of a sorting task, an ID style sorting task, and we thought there are going to be a lot of options that control how the sorting task works. It turns out that that isn't enough to cover the sort of tasks that we regularly want to create. And in particular, it seems that researchers keep coming up with edge cases and more complex things that they want to do. And in the end, minnow time turned out to be more than specifically a research-oriented tool. It's an interaction-oriented tool, where what we work with is with types of interactions that the users have with the various tasks. And we'll shortly get into how that works exactly. But I just want you to keep in mind that's where the flexibility of minnow time comes from. We want to allow you to create as many interactive experiences as possible in the easiest way that we can. Okay, so the basic unit in minnow time is the trial. In MinnoQuest, if you recall, we had pages that could contain questions, and in minnow time we have trials, and the trials are composed of three main parts. The first are stimuli. We can have a list of different stimuli with different properties of all sorts. that Minno can display. Then we have inputs, which are ways that the participants can interact, can react to the stimuli or to their instructions. And finally, we have interactions, which are um, a set of ways, essentially, that the input and the stimuli can interact with each other, or their sets of their sets um, of responses that Minno.js can have to actions from the user. So the complex part about Minno time are interactions, and I want to wait 1 second before I'll show you how it looks. So we have an array of inputs that can have that can react to all sorts of different user behaviors. And then we have a list of stimuli. In this case, it's just the word red. Oh, the word red in the color red. And then we have an array of interactions. Now, interactions are the most complex part in Minno time, also the most important, I think. And before we get into coding and before we get into designing specific tasks, I want to take the time to understand how interactions work and what the idea behind the activity timeline in Minno.js and how it's different than other players. So the idea behind interactions is that behind the scenes, there's a stream of events. And that probably made absolutely no sense to you. Let me say it in non-programmer speak. So by default, Minno.js doesn't do anything. It waits until there is an action or an interaction by the user. It can be a key press, it could be a mouse move or a mouse click. It can be sometimes the event that gets triggered is a timeout. Once there's an event triggered at the beginning of each trial, and when such an event happens, a user interaction or a timeout or something of the sort, then Minno.js tries to react to that event. And the way it does that, it goes through a list of contingencies. And for each list, it checks if some conditions are true. If so, it performs some actions, and if not, it just moves on. So what it looks like is this. We have some sort of event. It could be the beginning of the trial. It could be a user action. It could be a timer triggering. There's an event. And then we go through a list of conditions. And I'll show you in a second how these conditions look. And we check, is this the correct type of input? Has the user done something significant? We can check all sorts of all sorts of flags that are going on, or variables. We can check a lot of things in conditions. And if the conditions for a specific interaction are true, then we have the actions. We can show a stimulus, we can end the trial, we can give the user a score, whatever we want. But the basic idea is that we wait for an event, and if some conditions are true, then we act accordingly. For example, we can have the following progression. There's an event. Somebody presses I. we check the condition. Was the key E pressed? It wasn't, so we don't do anything. And then there's another event. There's a key press of E. We go back to the condition. Was the key E pressed? Yes, it was. And so we have an action. We show a stimuli. We show the word red. Okay. I'm going to go back to the code here for a second. The way this looks is we have a list, an array, actually, of interactions. And each interaction is an object with a description of conditions when it's triggered. In this case, at the beginning of each, at the beginning of the trial. And a list of actions to perform. In this case, to show a specific stimulus. And another interaction, if the event's name, the input equals next event, then end this trial. Okay, we'll get back to this, but this is the basic idea. The interactions are the part that make the trial work. They're essential to understand. They're essential to work with. Okay, and we saw this. Nice. Okay, so this was the can you still see my screen? Great. So this was the very basics of how minute time works. That's the structure that we're going to be working that we're going to be working with. And what I want to do in the next half an hour or so, I hope, is build a very basic task from zero and see how it works. Okay, before I go into the live coding, are there any questions? How anything works? Anything at all?
I have a comment. I mean, just another way to think about interactions. If you think about what happens in any trial that you ever had to program in any study, you always have to construct it from something happened and the program should react. Like this trial began, so I need to show the stimulus. Then perhaps the participant responded. I need to do something if the participant pressed I, if the participant pressed E. And that's pretty much all that we have in trials. That and timeouts. That's pretty much all that we usually would have in a trial. Like if the user pressed something or if time has passed.
Thank you. I think one of the thinking in events in this way is a bit different than what I know from other programs, in the sense that it's less linear, and that's sometimes it's a bit confusing at first. But I think when you get down to programming, it's a lot more intuitive. Describes the way we think about tasks a lot better, and we'll see a bit of that in the second session today. So we want to create a new a new trial, a new task, and as always, we never ever remember the syntax. So we're going to go to the documentation and start figuring it out. One other thing that I'd like to point out is that we saw yesterday that a lot of times we export our objects into sets, so we can inherit them with it. We can replicate them more easily. But when I start programming, I almost always start directly in the sequence, and then transport things into sets as I need them. Okay, so we go to the documentation. This time we're into time-sensitive tasks. And this time I'll go to an example to start with. Okay. As I showed yesterday, the example hold examples for all sorts of things that you can do. But there's this playground that you can work with. You can even run things in the playground, and specifically this this example holds a very simple trial that just displays something, and here we are, good. And let's just read through. So first of all, we have an input. We want the user to be able to interact with the with the trial, and for inputs, there are lots of types of inputs. The critical words or keys are on, which tells us what type of input it is, or what type of user behavior this listens to. In this case, it listens to a key press of space. It's a shorthand for on key press. And the handle, which is the name that we refer to this input within the trial, we'll see that later. Then we have layout. Layout is a different. It's a type of stimuli list. We can do this instead. The difference between layout and stimuli is that layout gets presented automatically, and you can't control it with actions, which is it's useful a lot of times when you have a set instruction in your on your screen. We'll use it in a minute and show how it interacts with stimuli. And in the end, we have interactions. In this case, we have only one interaction. We don't need an interaction to show this stimulus. But here we have input equals, and it equals to the value space. So if the input here, the input handle essentially equals space, this interaction will be triggered. And what we'll do is end the trial. Okay, so let's just run this to see that it works. And we have hello world, and I click space, and it goes away, and all is good. So I want to turn this into a simple sorting test, a simple sorting task. And in order to do that, we'll go through through each of these sections and fit it to what we want. And the end result that I'm looking for is a task that allows users to sort between negative and positive words, let's say. Okay, and let's just go through each section here and see how we want to change it in order for that to work. And what happens a lot of the time is that when I program things like this, is I start simple, and every time I want to add a feature, I figure out that I need to do things in a more involved and more complex way, and that's fine. That's fine. We'll see that we need to change things as we go, and that's really fine. Okay, so let's start with the input. The project implicit IAT famously uses I and E as keys for storing. And let's start with that. So I go back to the documentation, and what I want to see is API trial input. We want we're looking for here. We're looking for the key pressed input. Takes a key the key pressed input deals with key presses, which is what we're looking for. And the syntax is as follows. We have a handle, which is the internal name that we give the key press. And we have a definition of the type of input. And finally, we have which key to react to. So I copy this over. And replace this. And we want E and I. and want to give them meaningful names so that we can later refer to them. And what these inputs are, as far as we're concerned, is events. So we'll call them negative event and positive event. Okay, now these names are totally arbitrary. You can pick whatever you want. I suggest that you give them meaningful names so it's easier to read and understand what's going on. Okay, so now we told Minno.js to listen to these events. But if we play, go ahead.
I have a question. At first, I thought that like these, I guess that the green text were like predetermined commands or something like that, like space is or input equals, like you always have to write it that way in order to get that specific. You're saying here that you're actually making that up as you go and you have to define it somewhere else, or how does that work?
So it depends. It depends. Some of the keys have predefined values. So for on, for example, you have predefined values that I need to go to the documentation to figure out. Handle specifically is open. I'm giving this event a name, so that later on I can refer to it.
Okay.
Okay.
Yeah.
So it depends. It's a bit confusing. I'm not sure in retrospect that this should have been exactly the way that you know what, I'd go with this again. It's a bit confusing, but it's something that's really needed. You really need to give things names so you can follow so you can follow what's going on.
Yeah.
Okay? And you'll see that we'll use the keyword negative event later on, and we'll react to it in different ways.
So it'll just be like experience that you realize which one predetermined and which ones you name, because they don't have different colors on here. Different.
No, so the colors are strictly what type of variable they are. Green means it's a string, and white means it's in this case it's a key or object or just part of the syntax of JavaScript. And we have this orange for return, and we have, I think, yellow for functions, and we have red for numbers, and you'll find other editors with different with different colors. What they do all have in common is that they mark the JavaScript variables. They don't know about Minno.js specific syntax.
Thank you.
And the way to know whether it's something that you make up or not, it really depends on the type of the property. Handle just is the name of the input. So you give the name, but on is what kind of event is, what kind of input it is. So it's predefined, and you can see in the documentation what on can have, what kind of values on can have.
Okay, that makes sense.
Is there an?
Thank you
oh,
for.
sorry.
I was just going to say thank you for clarifying.
I had a question. Is there? I realize this is probably something related to the specific task you're building, but like my intuition would have been to call this like pressed E dot event and like or pressed I event.
That could work. The way I think about it is that I don't care if it's E or I. I care that it signifies a negative or positive event. Maybe in a different situation, I'd call it right event and left event. Depends on the context, really.
So negative and positive here are like represent the meaning of pressing E or I,
Exactly.
and not the fact that you've pressed E or I. Okay.
Exactly. And again, it's easy for me to think that way right now. Maybe if I had to make a trial that supports switching between them, then I'd rethink that. Maybe not. I don't know. It's it's very flexible and depends on exactly what you're doing. For now, the meaning seems to fit well to me, and we can have it whatever you want. Okay, let's move on. So we have the inputs set correctly. And now I want to jump all the way down to the interactions. So right now, the interactions, if you recall, are set to react to the handle space, which we don't have anymore. What we want it to do is to react to negative events and also to positive events. But this is string. We want more than one response. So I'll let you in on a secret that input equals takes arrays as well, and we can write something like this. Okay, something's happening in the chat.
It's fine.
Okay. Okay, so now we'll end the chat whenever we trigger either negative events or positive events. I'll show you. Okay, and space does nothing anymore. And I click I and we end the trial. Okay, but now let's make this trial more like a sorting task. So we want the media that we display to be meaningful. Let's just call it terrific. And now we can sort terrific into E or I. However, we want to give the users some indication of what goes where. Okay, what does E and I mean? So for that, what we want to do is create labels on the screen that tell us what E and I each stand for. So, so for that, we'll just copy this stimulus. Okay, if you remember, layout is just is just a type of stimulus. We can just use these as a template and ask ourselves what we want to do with them. Okay, so now we have two stimuli, and inside media, we have a specific word. There are several types of media. Look it up in the documentation. We usually use either the word stimulus or an image stimulus. Media type. And there's a shortcut for words, which is just writing the word as is without the object, but we'll keep the things simple and keep it as a word right now. So we want this to say negative E. Okay, this is a label, and let's keep it small, and no, just remove the CSS. If you remember from yesterday, CSS is the language that describes how things look on the internet. And if you look into the documentation of stimuli, you'll see an explanation of how to use this key. But for now, I'm just removing it. No, maybe this is the time to talk about what stimuli are and how they're built. So I mentioned, I think I mentioned that trials have three types of objects. They have the trial itself, which is the basic unit, and within trials there are stimuli, which describe what you actually see, and within stimuli there are media, which is the content of what you see. So the stimuli are how you see it, where it's located, what its color is, things like what its size is, and then there's media, which is the values themselves. Why it works that way is a long story. It allows for a specific type of flexibility that we needed. But in general, it turns out it's pretty easy to use that way. So the central key of each stimuli is its media, what exactly it displays. In this case, the word negative E. And what we want to do is tell it how to display this word. And for that, we go back to the API and to stimuli. And what we're looking for is the location attribute. In the documentation, a lot of time, you have a list of the content here on the right in gray. So location is an object within stimuli that looks like this, and you can set it. You can set each stimulus to be located within the canvas in percentage point. Let me show you. I'm losing the word here. So we copy the template for location. So the keyword is location, and what we want where we want this media to appear is let's say 1% of the from the left and 1% from the top. We don't want to say anything about the bottom and the center, the bottom or the right. Okay, so this will locate the word negative E at the top left. Let's see how this looks, make sure it works in the first place. Okay, so we have, we can't see the canvas right now. It's pretty elongated. We might want to change the size. But at the top left, we have a label that E is negative and is to the left. That's great. Let's do the same thing with the right. So the same thing. I want to call it positive I, and we still want it on the top, but this time we want it 1 point from the right. And we want to study, and here we have the labels that we want. Okay. Okay. So what we want to do next okay, there are several things that that we can do. Let's start with something that we already did yesterday. And instead of having just one specific word, let's have several possibilities. Let's randomize the words that we pick. Okay, so we add a media set. Let's call it words. It has an array. Words. Let's have terrific. And great and fantastic and horrible and just bad and gloomy. Here we are. Now we have all sorts of words that we can work with, and in a media set, all you have are media objects like this. And what we want to do here is instead of explicitly setting what type of word we work with, we want to inherit a word from here. So we just write inherit and from the word set. And now we'll just randomly pick a word from the sequence. Okay, I've got fantastic and it's positive. I'll click I, and that's it. Okay, I'm not going too much into into this inheritance part. We did it yesterday, and we'll get a bit deeper into inheritance later on. Okay, so now let's think how we want our test to look. What do we want to actually happen? So let's add a fixation. Okay, let's add a fixation before. Let's add a fixation before before a stimulus. I think that's a good thing. Or no, you know what? Let's do something a bit more involved, and let's tell the person the people if they the participants if they answered correctly or not. So right now what we have is simply a condition that ends the trial as soon as there's a response. What we want is to have a condition that knows to check whether the response is correct, and and only if it is correct to let the person advance. Okay, for that we need to somehow mark the no, I'm getting ahead of myself. This is really this is getting really complicated. Let's see just how we display a stimulus before we do complicated things. So as I said, layout stimuli don't need to be actively displayed. And so what I'll do, I'm going to create an array. And copy our target stimulus into it. Okay, and now if I run this this task, what I get is only the labels. In a second, since it loads, here we are. Here we go. I have only the labels, and we don't have the main stimulus. So what I want to do is have an interaction that tells the stimulus to appear in the first place. So let's see how we do that. We go back to the documentation, to the trial, and to we'll start here in advance. The structure of interactions is an object with conditions and actions. And we want to start with finding out what the condition is for doing something as soon as a trial starts. So we go to conditions, and the first condition that we have here is is begin, which is automatically activated at the beginning of the trial and is never fired again. So we want this condition, and we want to create a new interaction. It has conditions and it has actions, and we already have the condition which we want to use in order to fire it. You may have noticed that I had an error here. It went all red, and then I found that I need to remove this this bracket thing. Okay, now I want an action that displays the stimulus. So we go back to the documentation, we go into actions, and we have an action called showStim. Displays the stimulus, takes the stimulus handle, and instead we can use all for all stimuli. So right now we have only one stimulus, so it's fine to use all. And we have our action. Okay, and now we have this showing up at the beginning of the trial. Okay. Now let's say that now you're going to ask, why do we want it in stimuli instead of in layout? It's so much easier when it's in layout and you don't have to do anything. So let's say we want to display the word for a specific duration. We want we want the participants to see the word for, let's say, half a second and no more. What we want to do is trigger an event after 500 milliseconds. How do we go about doing that? In action types, we have an action that's called trigger. And what it does is activate an event. And if we set a duration, it activates the event after a specific duration in milliseconds. So what we do is go back to our interaction, and right at the beginning of the trial, we want to add another event. So what we're doing now is at the beginning of the trial, which is this line, we're doing two things. First, we're showing the stimuli in stimuli. And second, we're triggering an event that we'll name in a second after 500 milliseconds. Or let's make it 300. And let's give it a name. When you give names, you should always think of meaningful names, so you know. So later on, you know what exactly is going on. So let's call this hide stem event. Hide stem stimulus event. Now, I like adding event at the end of all my events, so it's really, really clear that they describe events. It's you don't have to do it. It's not part of the language. It's just, I think, a good practice for clarity. So now, at 300 milliseconds after the beginning of each trial, there's an event trigger. The event will be called high stimulus event. And if we want, we can do something when that event happens. Right now, we have two interactions. One triggers at the beginning of the trial, and the other triggers when the input equals either a negative event or a positive event. Nothing happens when the high stimulus event gets triggered. So what we're going to do is add another interaction that that should hide the stimulus that we have. So we have conditions, and we have actions, and we already have a condition that responds to a specific event. So you can just copy it here. And the event it should respond to is hide stimulus event. And the action that we want is to hide the stimulus. So we go back to the documentation and, and we have here, hide stim. And we want to hide all stimuli right now. So we can just copy this from here and go back here. And here we go. And it looks something like this. It's taking it a while to run. Maybe I have an error. So this is something that you should definitely know. Sometimes you will have errors in your code. There is no getting around that. And when you do, the browser offers you the browsers offers you various tools to deal with that. One of the most important tools that you get is the console. You can on Chrome you can go to more tools and developer tools to open the console. You have dev tools on Safari and Firefox as well, and you can see errors that happen. In this case, I have a timeout. Just took too long for the task to load, so so it halted. I'm not sure why, but the dashboard is working really slowly for me. Maybe it's the distance. So I'll just run it again, and hopefully it'll work. Here we are. So I'm not sure. Did you see that? Did you see the stimulus for 300 milliseconds? Yeah. Okay. Great. So now, cool. So now we have a more interactive task. Now we can control how long we display a stimulus. I think we've been running enough time with this. So, okay. So I hope this was enough for you to get the gist of how Minno time works. This is not remotely close to everything that we can do, but I think the types of interactions between the items were clear enough. And I want to give you a few minutes for questions, and then we'll take a short break and continue with reading through a stroke task. So if anyone has questions, so if something isn't clear, this is a great time.
Ella, there was one question about how you would counterbalance, like between participants, whether the I is negative or E is the negative one. Perhaps you can show it in your code.
Okay, so so counterbalancing, well, strict counterbalancing is a bit difficult. Probably the way to do it is is have different links for different participants, and then there's a way for the player to.
But no, but that's only because we don't count how many people are in each condition, but we do we can randomly assign them to conditions.
Oh yeah, it's easy to randomly assign in several ways. One way I think Yoav showed you yesterday that that you can shuffle and just randomize the order, and then since what we're using is meaning and not location and not that specific key press, it's very easy to have the locations of the labels randomized. What we usually do is have weight and have a block with each combination, and then randomize the order of these blocks.
Let's go to the code just for a second. I mean, all that you need to do is just put the template instead of E and I, right? Like you can do global dots, left key, or whatever, just to show how it looks when you.
Yeah. I'll show.
In the meantime, I'll just explain again. You know, in Qualtrics, for instance, every time you start a session, they know to go to the next condition. So that's how they keep pretty much equal numbers of each condition. We don't do that. So we randomly assign. So if you want equal number, well, you'll never get equal number in each condition. But if you run enough people, then it's pretty much 50-50.
We can use.
Well, I guess it's not really the left key; it's the negative key in this case, right?
Right. Or negative or negative key. You'll probably want to do something a bit more involved, because you want the location to be accordingly. Essentially, what you want to do is have. Essentially, what you want to do is every place in your code that depends on which side should use either a template or a branch in order to fit it to what you need.
Great.
Okay, let's take until like a 10-minute break.
Yeah, let's convene in 8 minutes, which is 10 after the current hour.
Let's convene in 8 minutes, and then we'll continue from there.